This is the continuation of a topic that I started a couple of weeks ago on metaphysics. Essentially, it can be described as what has gone wrong in metaphysics and how can we set it right. The way to put this into a bigger context is like this. We have two big areas of philosophy. One is the theory of knowledge, epistemology, and the other is metaphysics. What is there in the world? What is the world made of, including us? What is that made of? And these two can be regarded as at war with one another, or at least in tension with one another. In epistemology, in the theory of knowledge, what we want is the most secure knowledge that we can get. And that pushes us towards or disposes us towards particular beginnings, particular foundations in the theory of knowledge, which are not the best suited for the theory of metaphysics. We will get different results if we had approached the matter through what plausibly is the world like? What should we say about the world? These two things are in tension with one another. And what I want to do is to say how, in a sense, this has wrecked metaphysics, or at least has done damage to it. I think that's probably a better way to put it, because the situation is not unsalvageable, no matter how difficult it might be. And what I was saying last time was that there's a particular view that is dominant really from the 17th century onwards, from Descartes to Locke, Berkeley, Hume, including Leibniz, etc., and then on into Kant. And then from Kant, it then jumps into pretty much modern times with a sort of sometimes a very subjectivist view, phenomenological view, other times with a positivistic view in the 20th century. And these can be regarded as outcroppings of that same beginning in the 17th, 18th centuries. Epistemology begins to take over from metaphysics. It begins to limit metaphysics to a very great extent. And we are not out of that woods by any means at the moment. So philosophy is constantly crippled by these philosophers who had, in a sense, the good intentions in the 17th century. Descartes, certainly, Hume, Berkeley. These philosophers had good intentions, but it went very badly awry. And what I'm trying to do is to say something about how it went awry. It can be called a sort of, in that early period, early modern period, it can be called a philosophy of sensationalism. And I think it has had disastrous consequences. Now, what I was saying last time is that this sensationalism, in Hume's very pithy formulation, it's the idea that all ideas are but copies of impressions, sensory impressions. So sensory impressions give us our ideas copy those impressions. What that copying means is not a very precise idea, but ideas come from impressions. So there are no ideas without impressions. And the first thing that has to be said is that that idea is not really properly pursued by Hume, though he announces it as the beginning of his theory of knowledge. He doesn't really pursue it properly at all, because what he does very frequently is the reverse. For example, take the problem of causation. What he says is, even if we look minutely at the way in which things occur, we don't see any necessary connections between cause and effect. There's no impression there. If there's no impression, how are we getting this idea of necessary connections? Now, that's a very odd way to use what he has started with. He started with the idea all ideas are copies of impressions. Now, if he were adhering to that idea, what he would say is, well, we have the idea of necessary connections between cause and effect. Therefore, there must be an idea from which it's copied. If all ideas are but copies of impressions, and we have the idea, then that should settle the matter that there has to be an impression. But Hume goes about it the other way around. If we can't find an impression, then, well, what is he supposed to say at that point? What should he say? And that's where he becomes very unclear as to the consequences of all of this. What he ends up saying is that there is no impression of a cause-effect relationship. Therefore, we must have something else that gives rise to the idea. It just goes flatly against the idea that all ideas are but copies of impressions. So what I said last time was that, in fact, the idea that ideas are copies of impressions only really works when you have impressions. And you only have impressions of certain kinds of things, colors, etc. You have impressions there, maybe of, the weight of something. These are things which you might have an impression of. But many things don't give rise to impressions at all. And the example that I used last time was, well, relations. There is no impression of being a mother of. If Madeline is the mother of Alice, there's no impression of that motherhood. That relation simply doesn't have an impression attached to it. Relations in general don't. I can't think of a single case in which a relation has an impression. This is not just restricted to even relations. The problem exists even for certain properties. And that's, in a sense, what I want to go through today, and to lead into the modern physical world and what that says about these matters. Let's look at another example of a relation that obviously does not give rise to an impression. So suppose we have these two objects. Let me put them the other way around. These two objects, and this object is to the left of this object. So the relation is to the left of. Now it's, I think, obvious that there can't be an impression of to the left of that relation. If there were, then we would have to have a very strange circumstance in which, if I were to rotate around to the back of these objects, which, by the way, look, you're in that position now, that's how the camera is placed. If I were to be rotated around, what I would find is that this is to the right of this. Now, that would then have to flip my impression from left to right. And there is no such flip that takes place as I rotate through 360 degrees, rotate around these objects. Or to put it another way, and it's the same point, if I were to see these objects in a mirror, though I see, if there were an impression, I see them directly as having this to the left of this. If I see them in a mirror, I would have to see that whole relation flipped to this to the right of this. So there can't be any impression of leftness and rightness. And it's obvious that there isn't. So that shows, it's enough of a proof I think as any, that shows that there can't be an impression of that relation. So the question arises, is there an impression of any relation? I think my contention is that there isn't, that no relation gives rise to any impression at all. There are relations, but there are no impressions of relations as far as I can see. If you can think of one, then please put it in the notes or in the questions at the end of the video. Be very interesting to see. Is there such a relation that holds between objects where there's an impression of that relation? Don't see that there's any. So, we've covered now certain relations, and this seems to be, almost an automatic problem for the empiricists like Hume, but all of them. They focus entirely on impressions as things which give rise to ideas, but if they were to do so, we would have no ideas of relations on their own theory. And that's absurd, because we do have ideas of relations. In fact, they are perhaps the most important things we know and understand. And if their theory can't account for that, then their theory is really false from the start. And I think that's in fact true. So what we have is this long tradition from Descartes through to Locke, Berkeley, Hume, Leibniz, Kant, and on into the 20th century of epistemology, developed in such a way that it leaves out some of the most important things that we want to understand, those including relations. But it also leaves out other important things too. For example, Hume should really have been confronted with this point. But there is no impression of a logical connection or a logical necessity between propositions. But Hume relies on them almost entirely in his philosophy. Hume relies on the idea that there are relations between premises and conclusions which are sometimes necessary relations, necessary connections. He never answers the question, what is the impression of that logical connection between premises and conclusions, though he relies on it throughout. It's almost as though Hume is really refuting his own premises, his own sensationalist premises. As he goes through his own philosophy, he finds one exception after another in which it just simply doesn't work. That should have told us something. Kant is really just simply Hume with the addition of, as it were, sort of Kantian category badges placed all over it. And it's not much different from the philosophy you can find in Hume. He certainly understood Hume very, very well. And what he was doing was really adapting it. And he was adapting something which was really false from the start. I don't think that's often said about Hume, but it really should be, because I think that was the view at the end of the 19th century in British philosophy. It was that Hume had not really sort of done very much in philosophy, and we had to get beyond it. But how to get beyond it was something that no one seemed to understand. So let's move on now to not relations, but things which are sort of on the border between relations and properties. Let's consider mass. Mass is something very unusual. There is no impression of mass, and there is no impression because, in a sense, it's a theoretical term. A mass does not have any sensorium attached to it. There is no impression of mass. It's something which exists and is theorized to exist because it makes sense of the law of impacts, the law of impetus, the way in which one thing impacts upon other things by a conservation law requires there to be a notion of mass. We have this in a passage in the mathematician philosopher Hermann Weyl. He says, thus, for example, the inertial mass is no perceivable characteristic of a body, but can only be determined by allowing the body to react with others and then applying the impulse law to these reactions. The law asserts to every isolated body, a momentum may be assigned, this momentum being a vector with the same direction as the velocity. The positive factor m, by which the velocity must be multiplied in order to give the momentum, is called the mass. So it's not something of which we have any sense. You may confuse the notion of mass with something of ideas which we do have some idea of sense of. For example, weight. But weight is not mass. Weight is mass in a gravitational field. The gravitational field is accelerating the mass, and we have an impression of that as a weight. But we do not have an impression of the mass itself. Now that's a very interesting idea, but it doesn't appear at all. I mean, it refutes Hume directly. Mass is then a quality of objects, but it's a quality of objects of which there is no sensorium, no impression, gives rise to that idea. We have the idea, but there is no impression of mass to give rise to it. We have the idea because the concept makes sense of the notion of impact. Momentum makes sense in that context whereby one thing bumps into another thing. So if we see things that were outside of us, we're looking at an object. I don't know, again, take this. I look at the object and I say, my senses don't give me the idea of the mass of that object. I have an impression when I'm holding it of its weight, but I don't have an impression of its mass at all, really, other than this indirect relation through its weight. If I were on the moon, if I were in empty space, that impression of weight would disappear. And yet the mass is still there. So the mass is something, and it is as it were, a primary property of things. It's a property, not a relation, really. And yet we have no sense impression of it at all. And that refutes Hume directly, and Hume never considers this problem. So the idea that once we have that idea refuted, we should say that really that entire tradition should be regarded as, at that point, as to be put to one side, and we should really start again, not using impressions, but instead starting from the things which have some sense in our metaphysical view. So it really is the point where metaphysics should have come to the fore to replace these ideas of epistemology, where how we come to know things is really not a foundational thing, or shouldn't be, and yet philosophy is almost entirely in terms of that, as I'll come back to at the end. Now, to get momentum, we combine mass with something else, velocity. Momentum is mass times velocity. Now, velocity is another very interesting characteristic, because it also is not something of which we have an impression, really. When we are undergoing uniform motion in a particular direction, we are unable to experience or to sense the velocity. So take yourself driving along in a car. You're going at a constant velocity on a freeway. Now, suppose you're not accelerating or decelerating. You're driving at a constant speed in one particular direction. Then you can not have any sensation whatsoever of moving. If you were to black out the windows, which I'm not advising that, but if you were to black out the windows on your car, you would have no sensation of movement. The sensation of movement vanishes. There's a sensation of acceleration. You feel pressed back as you're accelerating, and you move forward as you decelerate. You sharply decelerate, you go forward. You sharply accelerate and you move back. So there is a sensation of acceleration, but there is no sensation of velocity when it's a constant inertial velocity. And acceleration is change in velocity over time, and yet you do not have any impression of constant velocity. You only have an impression of a change in velocity. That is extraordinary. Quite extraordinary. Now imagine if you're in a train. It's an easier example because trains run along straight tracks. If you're in a train, then the train doesn't give you an impression of how fast it's going. If you're in the train and you're not looking out the window, you can have a sense of no movement. It's fascinating. If you were to throw a ball from one side of a carriage to the other side of the carriage, the ball wouldn't suddenly move back to the back of the carriage in its passage. It's no longer attached to the train. It's in the air between us. The ball wouldn't move suddenly back to the back of the carriage because it's somehow not connected to the train anymore. Instead, it would go from your friend to me and catch it just as easily as I would if we were standing in a field throwing a ball. I once had a friend who, for whom we had an enormous argument about what happens if you throw something out of a window of a train. Her view was that it would just zip to the back of the train as soon as it goes out the window of the train. And I said, no, it doesn't do that. It would, in fact, land opposite where it was thrown in the train. The only thing that pushes it back at all is the wind resistance outside the train, because there is no wind resistance inside the train, so it's the wind resistance outside the train. But other than that, it goes in a direct line outside the window and falls, as it were, next to where we are in the train. She didn't believe it, and we had this argument, I think, for maybe 2 hours on a train. So we have misconceptions about this that really should have been solved in the early 17th century, 1623, which is when Galileo wrote his essay, Dialogues on the two principal world systems. In that dialogue, 1623, Galileo lays out the argument that we can't detect smooth, uniform motion. If we're inside it, it feels to us like no velocity at all. And it's called Galilean relativity. That's the name for this phenomenon, which is the name for the phenomenon you're experiencing when you're in a car or in a train. Galilean relativity. There is no sensation, no sensorium for a constant uniform velocity. Now that should give rise to astonishment, really. And I don't know that it gives rise to enough astonishment in ordinary people. People don't reflect on this enough. And yet it's an extraordinary thing. We have its most perfect expression in Galileo, but it doesn't originate entirely in Galileo. It's the best expression we have. But it's there in Galileo's predecessor, Giordano Bruno. Galileo he was a friend of Galileo's to some extent, but Galileo doesn't cite him, which is probably very wise, because Giordano Bruno suffered a horrific execution. It shocked the entire world. It would be very dangerous to repeat his ideas. But it goes back actually even further than that. One can trace these ideas back to an early 15th century philosopher by the name of Nicholas of Cusa. And Nicholas of Cusa was really the forerunner of relativity theory. And it's there in him that there is no place that's the center of the universe. That makes no sense. The sun is not the center of the universe. The earth is not the center of the universe. There is no center of the universe. That is just simply a wrong idea. And he said that more than 100 years, almost 200 years really, before Galileo did. So, what I want to do is read to you this passage from Galileo. It's one of the most beautiful expressions of this idea. Everyone should know this, but I don't know that everyone does. And somehow we don't learn from our own experience. This idea was not present in the Greeks, as far as I can tell. No Greek expressed this idea of the relativity of motion. So here it is. Here I'm going to read to you this passage from Galileo. Here goes. Shut yourself up with some friend in the main cabin below decks on some large ship, and have with you there some flies, butterflies, and other small flying animals. Have a large bowl of water with some fish in it. Hang up a bottle that empties drop by drop into a wide vessel beneath it. With the ship standing still, observe carefully how the little animals fly with equal speed to all sides of the cabin. The fish swim indifferently in all directions. The drops fall into the vessel beneath, and in throwing something to your friend, you need throw it no more strongly in one direction than another, the distances being equal. Jumping with your feet together, you pass equal spaces in every direction. When you have observed all these things carefully, though there is no doubt that when the ship is standing still, everything must happen in this way, have the ship proceed with any speed you like, so long as the motion is uniform and not fluctuating this way and that. You will discover not the least change in all the effects named, nor could you tell from any of them whether the ship was moving or standing still. In jumping, you will pass on the floor the same spaces as before, nor will you make larger jumps toward the stern than towards the prow, even though the ship is moving quite rapidly, despite the fact that during the time that you are in the air, the floor under you will be going in a direction opposite to your jump. In throwing something to your companion, you will need no more force to get it to him, whether he is in the direction of the bow or the stern, with yourself situated opposite. The droplets will fall as before into the vessel beneath without dropping toward the stern, although while the drops are in the air, the ship runs many spans. The fish in the water will swim toward the front of their bowl with no more effort than towards the back, and will go with equal ease to bait placed anywhere around the edges of the bowl. Finally, the butterflies and flies will continue their flights indifferently towards every side, nor will it ever happen that they are concentrated toward the stern, as if tired out from keeping up with the course of the ship, from which they will have separated during long intervals by keeping themselves in the air. And if smoke is made by burning some incense, it will be seen going up in the form of a little cloud, remaining still and moving no more towards one side than the other. The cause of all these correspondences of effect is the fact that the ship's motion is common to all the things contained in it, and to the air also. That is why I said you should be below decks, for if this took place above in the open air, which would not follow the course of the ship, more or less noticeable differences would be seen in some of the effects noted. No doubt the smoke would fall as much behind as the air itself. The flies likewise and the butterflies, held back by the air, would be unable to follow the ship's motion if they were separated from it by a perceivable distance. It's a beautiful passage. Galileo, 1632. Now, what he's expressing there is the relativity of motion. And it's the first expression of that idea that we have in a sort of an extended form. It was expressed then in the middle, roughly, of the 15th century. But it doesn't seem to have been expressed by the Greeks. It seems to have been a discovery that was made later. This, of course, matters enormously for Galileo, because what Galileo wants to say is that if the Earth is moving at a constant rate, then we are not going to feel the effects of that movement. The Church basically implied that if the Earth was moving, we should feel its effect. Galileo's argument is that that's not true. So we don't feel the effects of the diurnal rotation of the Earth, and we don't feel the effect of the Earth's movement in its passage about the Sun, the yearly passage about the Sun. We don't feel either of those movements. It feels to us as though we are still. That, when we are at rest, we are at rest. The thing is, if we were in constant uniform motion, we would still feel that we were at rest. That's the whole thing about your experiment on the freeway in the car. And that comes from these considerations made by Galileo. So velocity then. It seems to be a monadic thing, something that's a single thing which is inherent in an object, and yet it has no sensation attached to it when it's constant. Accelerations do, velocity does not. To think about why it is that as soon as you're in constant uniform motion, the sensation of motion just is not there. The question really is, and this becomes a deep question, why? And the only thing that one can say, I think one should say, is that the whole matter suggests, it's the beginning of the whole idea of the relativity of motion in Einstein's theory. So when Einstein tackles this whole problem of relativity, he's not doing it just as it were from nothing. He's mounting this on the back of the statements from Galileo. He's got Galileo already there. In Galileo, it's clear we have no sensation of being at a place, an absolute point in space. We have no impression of a uniform velocity in any particular direction. All of that has no significance for us in terms of sensations. So if I'm going to the east or if I'm going to the west, then there's the same lack of sensation of my velocity in both cases. If I'm going to the North Pole or to the South Pole, then I've got the same lack of sensation of that too. The lack of sensation of velocity is in all directions and at all times. What is this thing, velocity, which suddenly now seems very mysterious? Now, a second layer of mysteriousness enters into this in quantum mechanics. You've heard of the Heisenberg uncertainty principle. Well, it's an uncertainty with respect to two things, position and velocity. Now, what I just said was that both position and velocity do not have any sensorial characteristics. I can't tell where I am, and I can't tell how fast I'm going. I could be going 200 miles an hour, and except for the acceleration to get there, that's exactly the same feeling as if I'm going 20 miles an hour. So in quantum mechanics, these two things, neither of which do I have any sensation, get combined together. And an experiment that tells me, if you like, where I am can't be done at the same time as an experiment which tells me how fast I'm going. And that's something that you undoubtedly know and have heard about. But the interesting thing is that in an absolute sense, neither of those things are inherently properties of objects in relativity theory. Relativity theory already has the conclusion that nothing has an absolute position and nothing has an absolute inertial velocity. The only thing that these have is when you, as it were, adopt a coordinate system for both of them, then you have this indeterminacy. So that's the interesting question. What is this thing which I maintain, if philosophers had really thought about this matter in the way that they should have done from Galileo's time onwards, but certainly after Einstein's theory, then what one should say is, well, the sensational theory is completely mistaken, and can't be maintained. And it's further contradicted by this weird reciprocal relation that we have in quantum mechanics between measuring position and measuring velocity. Those measurements of position and velocity really must be frame relative even in quantum mechanics in order to be compatible with relativity theory. What we see from this is that velocity has to be a very strange object. It's really indicted both by quantum mechanics and by relativity theory, and it's by relativity theory all the way back to Galileo and, if you wish, Nicholas of Cusa. So we can trace this problem back even to there. Now that, I think, is profound because it gives us this link between relativity theory, quantum mechanics, and it also says to us that a vast tract of philosophy, probably the majority of the philosophy that has been current since Descartes, is wildly off, and that it's thrown metaphysics off because those early modern philosophers were very concerned, too concerned, I would say, with certainty or with high probability in knowledge, and not concerned enough with the cases where their principles of knowledge did not really properly apply to relations and to things like velocity. So velocity looks like something which can only have meaning in frames of reference. What then is a frame of reference? The philosophical tradition that almost everyone is taught gives you two bits of philosophy, as it were. The Greeks, Plato and Aristotle, presented to you in some form. And then we move really to what's called early modern philosophy, to the tradition that starts from Descartes, goes through Locke, Berkeley, Hume, includes Leibniz, Spinoza, and then on to Kant as early modern philosophy. And we're taught, really, that modern philosophy in the 20th century is a continuation of that. In the continental tradition, that becomes the tradition of the sort of phenomenological development of those ideas, and in analytic philosophy it becomes the positivistic, logical positivist implications of those ideas. But in some ways it's the same mistake in both, in thinking that that was really the proper tradition in philosophy. And no one gets any idea of anything else. That we are, in a sense, when students go through philosophy, they get this extremely narrow and false picture of what philosophy is and what its form is. It becomes a series of ideas which you imbibe, and most people end up being some kind of empiricist of some description. You imbibe the idea, but I say this is not philosophy. It's a strand in philosophy which puts epistemology first, but it is not philosophy. It is not the whole thing. it is a bit of philosophy and not what should be a major bit. It's a component. It's one of those things that enters into this dynamic tension between epistemology and metaphysics, in which other things like political philosophy and moral philosophy end up being a sort of collateral damage around the outside. But the central conflict between epistemology and metaphysics is a war that's engaged in between those two. I think if I were to have my way on this matter, I would suggest that students be taught metaphysics through a development of metaphysics from, of course, from Plato and Aristotle, of course, but in these, as a replacement for this early modern philosophy tradition of epistemology, I would suggest an alternative tradition of metaphysics. And that would run from Nicholas of Cusa to Leonardo da Vinci, passing through da Vinci to Kepler, to Giordano Bruno, to Galileo, then to Leibniz and Newton. And then that gets developed in a tradition that is almost submerged in the 20th century, but which is still at least partially there. It becomes submerged, I think fatally really, in logic. Logic becomes, in a sense, a symbolic form of metaphysics, of things and their properties, turns into quantificational logic. And I don't think that's the right way of understanding metaphysics at all. I'm entirely against that. But that's how metaphysics, as it were, gets passed off in modern philosophy classes to people who are not, who have not got the background to see where it's come from. But it comes really from that early beginning in Nicholas of Cusa and then the Renaissance, Kepler, Bruno, Galileo, etc. It's there. That is the beginnings of metaphysics in the modern period. We don't teach that. I think it would be a rarity, a glorious rarity for anyone to have gone through a philosophy department and to have understood that part of the tradition, but it's almost entirely missing. It was missing entirely from my own background in philosophy. So when I say this, what I'm saying is, I wish that I had been taught philosophy fully by having these ideas of metaphysics there so that they could be understood alongside this alternative tradition of epistemology, which is sort of pushed on us as what philosophy really is, how it develops in the modern period. And I don't think that's a legitimate concept. It's not how things really should go. We should regard the faults in empiricism, Kantianism. We should go through marking out all of the mistakes that are made in that tradition and understand that there therefore must be an alternative tradition in which more things are made sense of. And that would be the metaphysical tradition. So that's what I want to say. I want to, as it were, propose this as a syllabus for genuine philosophy. And I say this, and I'm always thinking here for American students of philosophy, because I really do. I'm sorry to say this. I utterly pity you in what you were given as philosophy by in your philosophy courses, because I don't think what you're getting is really a very fair shake. You're paying a lot of money, essentially for things which are, well, let me say, not particularly good. And that is really appalling. And it's the same in other parts of the world as well. Same in England, Britain, as well as here. So what we want really is a more balanced philosophical tradition, a philosophical exposition. And what I'm suggesting to you is that there is an alternative metaphysical development which should be used even in the 20th century, it's a counterbalance to that idea of logic as the proper development of metaphysics. Metaphysics as a sort of symbolic formulation that needs to have something more fleshed out in it in order to make any sense. But when modern metaphysicians do their job of trying to develop metaphysics, it's almost entirely in the tradition of things, individuals and properties. Sometimes maybe including some discussion of relations, but usually not. A good example of that is David Armstrong's presentation, or Lowe's presentation of that in Britain. What you're getting is a sort of a hamstrung metaphysics, not a metaphysics which is free from the constraints. Unfortunately, so even when we speak of the best of modern metaphysics, I think it's not enough to teach students what they really need to know and understand. So that's my sermon for the day.